Hello. In this video, I'm going to show you how to do correlation and regression using the GSS dataset in Excel. As you can see, I'm in my GSS data download. I've already prepared the data using the steps that we outlined earlier, and the variables that we're going to look at in this video are the variables in columns F and G. So the highest year of school completed, the mother, and the respondent's highest year of school completed. Both of these are interval ratio level variables, so we can do a regression into correlation using these two variables. And in our video today, we're going to go over the process for doing the correlation first, getting the regression as well, and then interpreting the output and writing an interpretation sentence and the regression equation. You can see, before we do that, you can see that I have, if you want to verify that your data is properly cleaned and prepared, just take a quick look at your variable drop down here and make sure that all of the missing, the don't know, or not applicable cases have been deleted per our data preparation video, and that's true for both of our variables here. So we're ready to go. I'm going to scale this down a little bit so that we can put all of our output tables over here on the right, and then easily transfer them into Word when we are done with our analyses in Excel. Our first step is to get the descriptive statistics for each of our variables. To do that, we're going to go first to the data ribbon here, and on the far right, select the data analysis, and this takes us into our data analysis toolpath. So we'll select descriptive statistics, click OK, and we've got to tell Excel where to look for those data. Now I've already been working with these data a little bit, so you can see that the input range is in there already, but let's go and select it again just for good practice. So I want to get descriptive statistics for both of my variables, and because both of these variables are next to each other on the spreadsheet, as in they're in adjacent columns F and G, I can get both the descriptive statistics for both of the variables together. If they were in different places, like one was in F and the other was in I, then I would want to run this process twice. So I've got my variables highlighted here, and I want to get both columns F and G, both my predictor and outcome variables, and I want to highlight all of the cases until I'm all the way at the end where, so I include all of the cases in our descriptive statistics. And there's about 2,300 cases in this data set here. I can see at the bottom there's 2,272. That's the number of the last row, and I'm going to take note of that for later use. You can see that's entered in my descriptive statistics here. Let's expand this, and we can see we can next select they're grouped by columns or rows. These variables are grouped by columns. That's why there's the header at the top of each column. And that's why I've checked the box here for labels in the first row. That tells Excel that the first row, where all the variable label names are, to transfer those labels into the analysis to help us keep track of what's what. Now let's select the output range for this variable. Now I want to put the output on this spreadsheet here. And I'm going to put it here in the N column, and I'll put it in N2. I'm going to put all our descriptive statistics over here to the right and our other statistics, and then we'll copy them over in a little bit. That's all we need, so let's go ahead and, oh, I did select summary statistics here. Do make sure you've selected that. Okay, and here we have it, and it's labeled both of our tables, but let's format them a little bit better so we can read them more readily. So as you can see, we've got 2 here, and I want to put this column N. I want to left justify it, so I'm going to go over to Home. I want to have everything lined up on the left side here, so I'm going to change the alignment of this one. I'm going to also do the same with column P, change the alignment of that column to the left. And now it's a little easier to read these tables. And here we have our descriptive statistics for each. Note that in the numbers here, these are our mean years of education by the respondent's mother and the mean years of education for the respondent. We're going to use these and some of the other data in our report. Let's go ahead and do our next step now. We'll get our correlation. And to do that, we're going to go back to the data ribbon, select data analysis, and this time go to correlation. Okay, and we're just going to simply use the exact same input range that we did for our descriptive statistics, and that input range is from F1 through G2272, but it just highlighted this whole range. There's some special formatting for typing it in, so I do suggest if you're having any issues to just use the manual highlighting like I have here. See, we just highlight both columns and we've got it. Make sure it's grouped by columns and the labels are in the first row. Let's check our output range. I want to put the output here in the N column, but down below our earlier table. So I'll put it in N19. That works. Okay, and now we have a correlation matrix here. To read this, it's quite simple. We can just see that there's, and again, I'm going to want to fix the headers a little bit here so that I can read it a little more easily. So I'm going to left justify this one again so I can see. And actually, the easier thing to do here is to highlight both of the cells you want to change the formatting on. Right click, go to Format Cells, and then Alignment, and you can select Wrap Text, and it'll wrap the text into the cell so you can read it. So that's a little easier now, just a little trick for you. And you can see that we can do the same thing over here. Another little trick you might be interested in is that you can, since I've already done wrap text here, if I want to copy this same formatting to another cell, I can highlight that cell, go over to Format Painter, click it, and then copy that format to any other cells I want. So I just did that to make it a little easier to read here, maybe help you with some formatting, but what we want to do right now is read our correlation matrix. And you can see now more clearly that we've got the highest year of school completed and the correlation of that with the highest year of school completed by the respondent's mother. So highest year of school completed is the respondent's own highest year of schooling, whereas the highest year of school completed mother is their mother's. And there's great research on this. It has been shown in other data sets and other populations that mother's highest year of schooling is a good predictor of her child's highest year of schooling. And we're seeing a modest correlation here too. We're seeing a correlation of 0.44. So we'll take note of that again. We have one more step left in our analyses. And to do that, let's go back to data here. Click Data Analysis and go down to Regression. We want to run the regression here because we can look at predicting respondents' year of schooling from mother's year of schooling, and that's what we'll get from our regression. Entering the data for the regression is a little bit different in that we need to identify one variable as our Y variable or outcome and the other variable as the X variable or the predictor. In this case, our outcome variable is the respondent's highest year of school completed, whereas our predictor is the mother's highest year of school completed. As just discussed, other research has seen this association. And you can see in the input range Y here for our outcome, I've already selected our outcome column, highest year of school completed, G column. And the input range for X is the F column here, and it's you should highlight all of the cells that have data in F. As you can see, It goes all the way down to, in this case, 2,272 cases. Okay, and let's see here. We want to make sure labels is checked. Labels tells Excel that these labels in row 1 are how Excel should label our data. We don't need confidence levels for our analyses today. Let's put our output range. Now let's check that. I'll go ahead and put it in N24. Just put it to the right of your data set so then we can copy them over. And that's all we need to run our regression. So click OK, and you'll get this summary output here. Don't be afraid. It just looks scarier than it really is. We're going to break this down. So let's see. Here we go. First thing to remember is that a regression has several terms, and I've already written out some of those terms for you over here in this regression equation. So remember that regression features this y-intercept slope format. So our y variable is the outcome variable, and in the regression equation, the outcome is equal to the intercept plus the slope times the x variable, which in this case is mother's years of education. So this is a general model for the regression equation. This is a specific regression equation as applied to our data. In which case, respondents' predicted years of education is equal to 9.86 years plus 0.35 times mother's years of education. Where did I get all these numbers, you might be thinking? Good question, and we're going to go over that. I just wanted to give you a little preview of where we're going with all the numbers here in our regression table. So, the first thing we're thinking about is our actual regression equation. Well, the regression equation, as we said, takes the general form of y equals the intercept times the slope, or plus the slope times x. Well, our intercept can be seen here in the bottom table. In this bottom table, we've got some great, very valuable information. The first is the intercept, and this is what you see in the coefficients box here, 9.857. This is measured in the same scale as our outcome variable, which is years. So our intercept is 9.86 years. And the next line, we have our predictor variable, highest year of school completed, mother. You can't see it, but I know it's there. Now you can see it. And this coefficient, 0.345, etc., is giving us the slope of the predictor variable. And we'll see those in our regression equation in a moment. Well, let's take a look. We have our intercept here, 9.86 years, plus this term for the predictor. So that is the slope times mother's years of education. Perfect. And another thing we want to note in this table is that we get a t-statistic for both the intercept and the predictor, the slope, that is. And we can interpret this t-statistic like you would any other t-statistic, and by using the p-value here is the most convenient way because Excel has already found the p-values for you. So it's telling us that this intercept has a p-value of 0. Well, 0 is definitely less than 0.05, so we know that this intercept is significant. It is a good, it's good in the model, it's working. And the same thing of our predictor, we know this is a good predictor because the p-value is very low. It's much less than 0.05. I know that because I can read this scientific notation, but if you're not able to read scientific notation, when you see a number like this where you've got digit with some decimals and then the e dash some number, that's telling you the number of this number here on the far right, in this case 108, is telling you the number of zeros after the decimal before you start getting to the 1 referenced over here. So this is quite a bit less than 0.05 or 0.01 even. So we do know this is a good predictor. If this p-value is above 0.05, we would say this predictor is just as good as anything else. But because the p-value is below 0.05, we know this predictor is different. It's working. It's a good predictor. It's not the same as just any other predictor. Okay, so there are a couple other terms that it's good to pay attention to in your regression. Specifically, the R-square is usually of interest in articles and research that's using regression. The R-square tells us the how well the regression model fits the data, fits the predictions specifically, and it's telling us the accuracy of the model. This is sometimes called the coefficient of determination. And again, it's just telling you how well this fits the model. An R-squared value that's closer to 1 is a better fit. Our R-squared value isn't especially high, but given these other data in our model, I'll say this is a reasonably good fit. And we can see one other term here that might be of interest to you in the future. Multiple R refers to the correlation, the regression across if we had multiple predictors in the model here, which we could do easily enough, and it would just be giving us a weighted multiple correlation. When you just have two variables like this, R squared can be found by actually just taking your correlation and squaring it. In our case, our correlation is 0.44. And you can get your number of observations here. Finally, the ANOVA table tells us the probability that this output is by chance. So it's saying, it's another way of measuring the fit of the regression model. Essentially, if the ANOVA value here, which we use the F statistic to interpret, if the F is significant, then this model is not due to chance. You reject the null hypothesis that the model's due to chance. You say, hey, the model's not due to chance. This is showing us a good model. There's a real effect here. And we can see that's true of this model because look at the significance. It's extremely low. Again, P is way less than 0.05. And we can see it's the same significance as in our t-test down here. That's true because we only have one predictor in the model. Okay, so now we've explored these tables. Let's do a couple final things to get our data collected here and our results completed. First thing is that you're going to want to transfer over your descriptive statistics. I would recommend transferring the tables separately. So as in the highest year of school completed for the mother, your predictor, highlight the area, copy the cells, go into Word, and paste that table in. And you can sorry about that. So you can see it here, and you can still adjust things in this table if you want, like if you're bothered that there's no lines or borders, go ahead and click this square here. You can see I'm hovering near. Click that, it'll highlight your table, and then you go up here into the paragraph area of the home ribbon, and this box icon here, if you click the down menu button and select all borders, it'll put all your borders in your table there. Make it a little bit easier to read. Let's get our other table. I'm going to copy those data over. Same process, I'm just using Control C to copy it, Control V to paste it, and I can do the same thing with the borders if I want. You can get the borders to pop up here if you're quick enough. Okay, and these are our descriptive statistics, and you should put in a page break after the descriptive statistics because it just makes the layout easier and I prefer to read it that way. That's the main reason. Excuse me, Mom. Oh my goodness. So now let's copy over our correlation table. This is a correlation matrix. And again, you can adjust the borders in this just like we did before. You can see how they're they're inconsistent because of how I copied the formatting earlier. I can fix that by just going to all borders and fixing those, setting them to be the same. Now finally we want the summary output for the regression, and you can copy all of this. Now I don't need these estimates here, the lower 95 and upper 95%. So to copy over your tables, get your summary output for your regression. And I would again, I know it's a few extra minutes to copy these over separately, but it will be worth it in case you have to move them around or you want to reference them differently in the table. So we copy these over. You should put a heading on each table, like you see here. This is our ANOVA. These are our intercepts. So here's your summary output. You can include this in the appendix for your lab report. And you get your univariate statistics from the descriptive statistics right here. And you can report that information, especially the mean, standard deviation, and the N. You specifically want to report those especially. Chill out. You don't need to chill out, but this cat that's going crazy next to me does. We're almost done. Everybody just relax. The last thing I want to show you is that in addition to writing out the regression equation here for you, you should write out your regression equation as well using a similar format as I did right here, and write a results interpretation sentence for the correlation. And you can see that I've done a nice example sentence here for you. As mother's level of education increased, and I've given the mean for the mother's level of education, 11.7 years. Respondents' level of education increased, and their mean was 13.9 years, comma, R, and then I've put in the degrees of freedom here, and that equals correlation of 0.44 as we saw, with p-value of 0.00, less than 0.001. Okay, and the key things in this sentence that you want to have in your lab report results interpretation sentence, and on your results interpretation sentences anywhere else, especially the final, is that both groups are mentioned, both the predictor and outcome variable, and the mean for each group is included, as well as the test statistic, the degrees of freedom, the observed test statistic, and the p-value. So with that information, you should be well prepared to head on your journey of doing correlation and regression in Excel on the GSS dataset. Live long and stat on.